Hello everyone. In this video, we are going to learn how to perform cloud masking. We are going to do two things. So the first one is that we're going to apply the cloud masking function that we have here. So this is the mask S2 clouds function. And we're going to use the map function to apply it to every single image in the filtered Sentinel image collection. And after doing that, we're going to analyze this cloud masking function and try to understand how it works. Okay? So, let's apply it using our map function. So while I'm typing out the code, please take a look at the image down below here and try to see the cloud cover right there, the center part of the island. And by the way, this is Pilar Island. And I'm going to type .map and then mask S2 clouds. Okay, let's not forget our semicolon. And then if we run it, please observe the changes in our data. So as you can see there is a significant reduction in the cloud cover. Now this is exactly what we want. Okay, the lesser the cloud cover, the better. Okay, so now that we know the advantage of using this cloud masking function, let's try to understand how it works. Okay, let's try to understand it line by line. Okay, so the first line inside the function, by the way, the parameter is an image. Okay, and then var QA is equal to image.select QA60. Now what is this QA60? Okay, let's try to visualize this QA60. Okay, so I typed out a piece of code here. Var image is equal to EE image. And then I selected one image from our filtered Sentinel image collection. Okay. And then let us try to load this particular image. So image. So let's run it. Okay, so here is the image. This is a single image. Okay. Now, if we go to the inspector and click here anywhere in the image. So let's go to objects and then let's go to the bands. So we have a total of 16 bands here, the index from 0 to 15. And in the index 15, we have QA60. And take note of the data type here, which is an unsigned int 16. So we'll get to that later. So here is the QA60. The QA60 band is actually a bitwise map of containing our cirrus clouds and also opaque clouds. So you will see that later. We're going to load it. We're going to select this particular band. And let's select QA60 here so that we can see what this bitwise map looks like. Okay. Oh, I forgot. They should not have an RGB viz. So let's run it. Because this is only a single band. So layer 1. So I'm going to use the maximum value, which is 2048 for this. You will know why later. So for now, so as you can see, we have right here. Okay. So if we click on these gray areas, these are actually opaque clouds. So QA60, we have a pixel value of 1024. Now, if we loaded a lot of data, then we will actually see cirrus clouds here with pixel value of 2048. But for this particular image, we don't have it. Okay. Okay, so now let's move on to the second part of the code, the second and third lines. Okay, so var cloud bit mask is equal to 1, and this operator here 10, and then cirrus bit mask 1, and then this bitwise operator here 11. Okay, so let's go to our notepad and see what these mean. Okay, so again, we have an unsigned integer, right, for each band in our filtered Sentinel. And it can hold values from negative 32,768 to 32,767. Okay, but in this particular case, our maximum value for the QA60 is 2048. Okay, and then as you can see right here, this is actually a left shift. So you will add 10 zeros to the right. So basically you are adding 10 zeros to the right of this one. So that will result to this. So this is the binary representation, and the decimal equivalent is 1024. So same thing happens for 1, and then this left shift 11. So this is the binary, and this is the 2048. This is the decimal equivalent. Okay, so now that we know that, let us now move on to this fourth line of code, which is var mask. Okay, so let's try to understand this bit by bit. So we have qa.bitwise and cloud bit mask. So what is this bitwise and? Okay, so how does this work? So let us assume, so qa again, let's recall that qa right here is our bitwise map right here. Okay, this is our QA60 band. Okay, and we have three values: 0, we have 0, 1024, and 2048. Okay, now qa.bitwise and cloud bitmask. Okay, so we are going to compare the pixels. Okay, qa.bitwise and cloud bitmask. Our cloud bitmask is 1024, and qa. So again, three possible values for QA: 0, 1024, and 2048. So let's say, for example, that our QA is 0. So we have a pixel in the image that is 0. And then perform a bitwise AND to cloud bit mask. So how do we do that? So let's go to our notepad. And this is the bitwise AND. So we're going to take the binary equivalent of 0 and the binary equivalent of 1024, and we're going to perform a bitwise AND. So 0 and 0, that will be 0. So please review your logical operators. So 0 and 1, so that will be 0 as well. We will only get a 1 if it is 1 and 1. So 0 and 0 is 0, 0 and 1 is 0 and 1 is 0, and 1, 0 is still 0. We will only get a resulting 1 if they are both 1. So that is the property of the AND. So this is bitwise AND, and the result of bitwise AND 0 and 1024 is 0. Okay, let's go back to our code. So for this bit of code, we have a value of 0. Now this .eq, so 0.eq 0. So if this is the value here is 0, and it equals 0. So this .eq will give us a value of 1. Okay? So if you're wondering how these functions work, then you can take a look at the docs here. And then we have another function here. We have another method here, AND. Okay, so we are going to, let's examine this first. So QA, again, our value is 0. Then bitwise AND Cirrus bitmask. So instead, so we have 2048 instead of 1024. So the same thing will happen, because if you take a look here, so if we have 2048, so the 1 will just be right here, and then this will be 0 for 2048. But it will still yield the same result, because 0 and 1 that will still be 0. Okay, so we will still have a 0 for this, and .eq 0 is still 1. Okay, because they are equal. 0.eq 0, that is 1. So 1 and 1, that will equal to 1. Okay, so that's basically it. Okay, so basically if you try it to more examples, so then you will realize that all of the 0 values here will get a 1 result here in our mask. And then we're going to return the image.update mask. Excuse me. So update mask. So here is what update mask does. Updates an image's mask at all positions where the existing mask is not 0. So that's basically 1. So it's going to update the mask in every single band. Okay, so let us now try to load. Let's now try to apply this function to our image, this single image. Okay, so var mask, so let's name it mask, is equal to mask s2 clouds. Then let's input our image. Okay, and then we are going to load this mask. Okay, so let's try to see if we inputted it correctly. Okay, so there you have it. Oh, this is not it. 2048. Okay, so apply. Okay. So this is what happens actually. So the gray areas correspond here to the clouds, right? And they are not included now in our image. Okay? So that is what happens. So we updated our mask, and all the zero values here got 1. And this is now the result after applying our function to the image. Okay? So as you can see here, so it's not perfect. So there are still some clouds there. But if you take a median in an image collection, then these areas with the clouds here, in other images, these have pixels that are not clouds. So you will get a better result there. So that is actually what happened there when we got the median in the first time we applied our the cloud masking function to every image in the filtered sentinel. Okay, so that's how this cloud masking function works. So I hope it all made sense. And if you have questions, so feel free to send me a message or an email. So thank you for watching this video. I hope you learned something new, and I will see you in the next videos.